Welcome to Short Planetary Geological Essays, narrated by Daniel Hutchinson. Ancient Rivers on Mars. The evidence is overwhelming that liquid water once flowed, forming river valleys on the surface of Mars, billions of years ago. Curved and branched channels have been seen in images taken of the surface of Mars from space probes dating back to the Mariner 9 orbiter. These river valleys are called valles, and plural valles, the Latin word for valley. The flowing water carved out flow channels and also formed large, streamlined islands. We first have to start with a source of water. This source can either come from underground or through precipitation from the sky in the form of rain. With a sufficient amount of water produced, that water reaches a critical point where it has to go somewhere to move from its original source. With the water emanating from a higher point on the planet's surface, gravity will direct the water as it begins to flow to a lower point on the planet's surface. With this gravity-controlled directing of the water, geological features will start to form as the water meets whatever large or small obstacles within its path of flow, whether it be ice, rocks, sand, etc. Also within the diagram are some different shapes of bodies of water left over, having formed in relation to what obstacles the flowing water encountered. A meandering shaped channel is formed analogous to the shape and forward movement of a snake's body. The forward flowing water's action of cross-cutting and down-cutting at the same time into the layers of rock, gravel, and sand leave behind ravines, valleys, river islands, pinched-off channels called oxbows, and multiple branching flow patterns, just to name a few. Now back to Mars. The water on Mars originated in areas of collapsed terrain, where the ground ended up forming into mesas and large blocks. This collapsed terrain has been called chaos by planetary geologists. The water then flowed to lower elevations and created an ocean to the north that was one-third the surface area of Mars. With floods of liquid water erupting from the ground many times, and Mars being very cold, ice would have quickly formed on the top of the rushing water. This situation allowed the water to flow underneath for some time. Mars has a thick shell of ice under its surface. Perhaps in the planet's distant past there was a vast interconnecting layer of water under it. If an asteroid, fault, or volcanic eruption caused this thick shell of ice to break, at some point or multiple points on the surface, water would be able to pour out onto the Martian surface. The valley networks on Mars are channels that closely resemble streams and drainage basins similar to the ones on the Earth. These channels are branched. However, these branches are typically shorter on Mars than on the Earth. Most of the channels on Mars do not exhibit a high branching density, but in some places the stream branches are in fact as dense as some on Earth. Mars's channels display meanders, oxbow lakes, cross-cutting and down-cutting action, streamlined islands, and many other geological processes associated with liquid water running over the planet's surface. Many channels end in low areas such as craters. At times, alluvial deposits called deltas form where the stream has entered a crater, appearing just like a stream entering a lake, like on Earth. These networks happened on Mars' distant past, when Mars was much warmer and wetter. Thank you for watching this short planetary geological essay about ancient rivers on Mars.